Hello everyone. My name is Prakriti Joshi and with me is my teammate Kea Desai. We are students from Rutgers University and as part of our Capstone project, we have worked on emotion recognition in Reddit comments. We have followed this 6 data mining steps as part of our project. Here is an overview of each of this step. So the initial stage is a problem definition and the scope of the entire project. So our goal is to classify emotions into 28 categories based on the Go Emotions dataset on Reddit comments. Next comes the data preparation step wherein we clean and prepare the data which can be further judiciously analyzed and modeled. In the data exploration stage, we perform univariate analysis to analyze the distribution of data and emotions in the data, and also bivariate analysis wherein we are interested in finding the correlations among emotions. Since our data is textual data, we have also performed analysis to find association of words with the emotions. Next comes stage 4, which is an important stage of modeling. Since our problem is a multi-class classification problem, we have used models such as naive-Bayes, perceptron, and bidirectional LSTM to model the textual data. The evaluation stage consists of accuracy classification matrix such as accuracy confusion matrix to better analyze these models. Our main aim is to create a web application to deploy the entire model and also display our data analysis. So here are the stages and we explain each stage in detail as we go on. Starting with the basic step of problem definition. Our goal is to classify emotions in any user input sentence, English based sentence, into 28 categories, and we do this by training a model on Go Emotions dataset of Reddit comments. So our motivation for this project stems from the very basic human experience of emotions and how detecting emotions is central to any social interaction. So once a model is created, it can be extremely useful in chatbots and virtual assistants. Also, it can be used to better understand humongous reviews, comments, tweets, which stem from various online platforms. And also, it can be used to detect harmful online behavior on such platforms. So the scope of this project entails data exploration of the Go Emotions dataset to better understand the distribution of the emotions and the underlying correlations in the emotions. Also, we aim to build a multi-class classification model to determine emotions in a given text. For that we wish to implement naive-Bayes, multi-layer perceptron and LSTM and compare the efficiency of the models to for text classification. For the final goal, we aim to create a web interface to present the results of this both stages in the form of a dynamic system wherein the user can see data analysis of the data as well as give a user input sentence and an emotion will be displayed for that sentence. So the next stage is the data preparation. This is a stepping stone for data exploration and modeling. So this stage is crucial in terms of preparing the raw data and transforming it into something useful. So firstly, a little about the data. The data source is the Google research team GitHub repository. They presented this paper in the ACL conference. The unique feature about this data is that it has a vast emotion taxonomy and also it is quite recent, so not much work has been done on this data. So coming to the data description, this data has around 58,000 records of data and the data contains English Reddit comments and each comment has a label associated with it referring to the emotion in the comment, and it also has a neutral category. Now a particular comment can have multiple emotions associated to it and the 27 categories are as follows. It has positive emotions such as admiration, amusement, gratitude, joy, love. And also it has negative emotions such as anger, annoyance, disgust, and so on. So here are the 27 categories plus a neutral category. Coming to understanding how the data is actually prepared. So comments are extracted from the popular Reddit comments, and also non-English comments are removed. So this data is limited to only English comments for now. Also, the authors of this paper and the data removed adult, offensive, and religious comments. However, some of the vulgar comments and words are preserved to better get an understanding of negative emotions. Also, NLTK word tokenizer was used to select comments of length 3 to 30. Here is a snippet of the data structure. So here is the Reddit comment, and here is the label associated to that comment. As you can see, the emotions are encoded in terms of numbers from 0 to 27, and a particular comment can have multiple labels, and this is the comment ID which is not relevant in our case. So coming to the data preparation step, we clean the data, and we have split the data into train, validation, and test split. The importance of this split will be explained in the modeling stage. And also what we have done is, for the modeling stage, we have started with simpler models first, while grouping data into three categories of sentiment classes: positive, neutral, and negative, and grouping emotions into broader categories, so that if a model works for smaller number of classes, we can extend it to a higher number of classes. So we have, for the data, we have grouped the labels and prepared the data. So here is the sentiment classification. We group the positive emotions and name them as positive class. So the label for that is 0. We encoded into 0, 1, 2. And similarly, we have done that for negative classes and neutral classes. And here is the grouping of emotions into broader classes such as anger, joy, fear, sadness, surprise, and neutral. So as you can see, the 28 classes have been mapped to these 6 classes, so that the first we can try our models on these 6 classes and then extend to 28 classes. Here is the encoding from 0 to 5 indicating these classes.
I'll be going through the next stage of data exploration, wherein we see how our data is distributed among all the emotion categories. So, starting with the basic summary statistics of our data, we have 58,000 comments in the data after filtering and cleaning, which we can use for training and testing. We have 27 emotions plus a neutral category. There are 1.6% of the data points which are marked as unclear or difficult to read. So again, these data points cannot be used and need to be filtered out. Next, number of tables per example. We can see that 83% of the data has a single emotion associated with the comment, and around 17% of the data has multiple labels, with majority having 2 labels, followed by 2% of the comments having 3 labels, and only 0.2% of the data having 4 plus labels associated with a comment. Next, we have divided our data into 80% training examples, 10% of testing, and 10% of validation examples, which comes around 53,000 data points in training and 5,500 data points in testing and validation each. Next, we are interested in seeing uh, what is the distribution of these data points into each of the emotion category. So let's start with our univariate analysis. So here the bar plot shows the distribution of the data points into each of the emotions. So we can clearly see that the neutral category has maximum number of data points of around 17,500, followed by approval of around 5,000 to 6,000 data points, followed by admiration, annoyance, and so on. And the emotions of nervousness, relief, grief have the least number of data examples present in our go emotions data. Next, as we have explained before, in order to make our task easier by starting with less number of categories, we group each of the 27 emotions into sentiments of positive, negative, and ambiguous. So let us see how the sentiments have, how many emotions or data points they have. As we can see, 40% of the data points or the Reddit comments have a positive sentiment, 26% have a negative sentiment, and 12% have ambiguous sentiments. We can explore this further by looking at all the emotions that lie in each of the sentiments and what is the distribution of it. Here we can see how all the 28 emotions are classified as either positive, negative, ambiguous, and how are they distributed. So in positive sentiments, we have maximum data points for approval, admiration, gratitude. In negative sentiment, we have maximum data points for annoyance, disapproval, disappointment, and ambiguous sentiment have the emotions of curiosity, realization, confusion, and surprise. Next, we see how the data is distributed into our six broad categories. So 40% of the data points or the Reddit comments have the emotion of joy, followed by anger, surprise, sadness, and the least amount of data points are present for the emotion of fear. Again, 22% of the data points lie in the neutral category. Now it will be very interesting to see if there is any relationship among the emotions that we have. So we can take a look at it via bivariate analysis. So for categorical variables, we apply the test of chi-square. Here is an example of chi-square test conducted for the emotions of admiration and amusement. So as mentioned before, around 17% of the data have multiple labels associated with it. So if any of the comments of admiration and amusement occurring together, we know that there is some correlation between the two. So this is the chi-square test helps us in identifying this relationship. Here we can see that the p-value for this test is very low, 1.29 raised to the power of minus 11. So we can conclude that there is strong dependence between admiration and amusement. Now to look at this chi-square test results across all the emotions, we employ a heat map where we can easily interpret our results. So lower the p-values, we can conclude that there is dependence between the variables, and higher the p-values, there will be strong independence among the emotions. So as an example, let's look at the column of grief. There is a strong dependence or lower p-value for grief with neutral, sadness, remorse, optimism, and nervousness, and there is strong independence with the emotions of surprise, relief, realization, and pride, and love, which is quite expected. But as we can see, it shows there is dependence between joy and grief, which does not make sense to us. So there are some outlier points present, like approval and admiration should have high dependence, but it has a very high p-value. Similar goes for joy and amusement. So the correlation which are quite obvious to us among the emotions are not entirely captured by our data set, but they are captured to some extent. Next, in order to see what are the words appearing in the comments that we can classify it as positive, we have made a word cloud out of all the comments marked with positive sentiment. So the size of the words are directly proportional to the frequency with which they occur. So love, good, like, glad, right, no, best are some of the words appearing very often in our positive sentiment examples. Similar analysis has been done for the negative sentiment words. So here there are words present like bad, terrible, sorry, weird, mean. So it clearly, these words help in identifying the negative sentiment in the uh, comment. But there are some words appearing like people, still, no, which are neutral words which do not actually help in identifying the sentiment, but they do appear in the comments a lot. So this is a good way of looking. After preparing our data and exploring our data comes the stage of modeling in our project. We want to develop a model wherein we feed any sentence and the model predicts the emotion associated with that particular sentence. So I'll begin with um, the steps that are involved in a typical text classification problem. I'll be going through each of this in detail in the coming slides. We pass our data through a tokenizer, which is the process of splitting or breaking our sentence into individual words called as tokens, which then go through pre-processing of removing stop words and stemming and lemmatization. Next comes the stage of feature engineering, which prepares our data to be fed into the model. Bag of words, TF-IDF, and word embeddings methods are employed in feature engineering. Next, we build our model, which is finally evaluated. Starting with tokenization. As I explained, we want to create individual words called tokens. We have used two types of tokenizers in our data. First is the regular expression tokenizer, which basically splits a string into substrings using any regular expression. And second is the tweet tokenizer, which preserves the punctuations and case. In our data, since our target is to identify emotions, punctuations such as exclamation points, multiple exclamation points, suppose a sentence has, or if a sentence is in all caps, that says something about the emotion in that text, so it is important to preserve both. So the libraries that we have used for this purpose is NLTK and sklearn. After tokenizing comes the step of pre-processing. We remove the stop words, which are the most commonly occurring words in the English language, which are the and to, which do not add any weight while identifying or predicting the emotions. Then we stem the words, so we basically generate the root form of each of the words. So playing and played count as play only because their underlying root is the same. Lemmatization is a more complicated process wherein we identify the part of speech in any word. So have becomes has and is becomes be.
So, moving to the second stage of modeling, again, our task is a multi-label classification for 28 categories. And for this, we now move to deep learning sequence models such as LSTM and bi-LSTM. These models are called recurrent since for a given current time step t, the output depends not only on the current input. However, it also depends on the information from previous time steps, and in this way, sequential information is encoded very well in and preserved in the such models. For text, we need such sequence models to have long-term information encoded in this, since words are interdependent on each other and not just independent inputs. So, we move to LSTM and bi-LSTM models. Just an overview of the entire model architecture right from the text to the model output. We have a text sentence. We first tokenize it into individual words. These tokens are converted into indexes, and this token indexes are passed to an embedding layer which converts individual indexes to a tensor or a vector of such indices. This vector is passed then to consecutive LSTM layers, which has hidden states and cell states to process sequential data, and the output of this LSTM is then passed on to a feed forward neural network, and the last layer of this feed forward network is an activation function which then produces an output. The last activation function is generally a softmax or sigmoid for classification problem, and then a binary cross entropy is calculated. Binary So moving to the model parameters, we have used the PyTorch framework to implement the LSTM. Also, we have used the glove embeddings, which are pre-trained vector representation of words. So as I explained in the previous slide, the activation function commonly used for classification problems is the sigmoid function. So in our case, since it's a multi-label classification problem, a particular text can belong to multiple categories of emotions. That's why a sigmoid function is applied to output neuron for each particular class. So the sigmoid function is essentially represented by this, and it has output from 0 to 1. Thus, for the final layer, the output for each class is between 0 to 1, representing belonging to that class. Uh, so, the multi-level classification problem is treated as C-independent binary classification problems, where the output score determines if the text belongs to that emotion or not, and each emotion is independent of one another. Continuing with the model parameters, the output vector is in this form, and for the training we have to use a loss function, and the most popular loss function for binary classification is the cross entropy loss function. The framework is that for each class, Si represents score for class I, and Ti represents the ground truth value for belonging to that class. We are using separate scores and ground truth values for each class since it's a multi-class problem. Now, the cross entropy loss can be calculated using this formula. So, if the ground truth value Ti is 1, that is, it belongs to the class, and the score is also 1, we have this log 1 into 1 as 0, and this term also as 0. So, the loss is 0. However, in case of misclassification, if the ground truth is 1 and the score predicted is near 0, we have log 0 as minus infinity, and hence the loss value is quite large. And for the multi-class classification problem, we have the final loss as average loss across all the classes. So here is an example of the LSTM loss plotted as a number of epochs. So we have plotted the cross entropy loss for both training and validation. Now, this kind of analysis is used to detect overfitting in training. We can see that the training loss keeps on increasing while the validation loss becomes constant after a certain point. So this point represents overfitting, that after this point the model starts to overlearn and will not generalize well to unseen data. So we use this to determine the number of epochs and as a kind of stopping condition for our training. One important use of this loss function and accuracy is for hyperparameter tuning. In our model, we have hyperparameters such as learning rate, regularization parameter lambda, and batch size. So we use the validation loss and accuracy to determine the optimal values for the hyperparameters. We implemented a grid search kind of approach to determine the optimal hyperparameters, and these are the optimal values in our BioSTM for emotion recognition. And also the sequence length given to the LSTM models is 30, since average length of the comment is 15, so we have kept the maximum length as sequence length, and the hidden state dimension of the LSTM is 256, and we have stacked two LSTM layers in our final model. To the stage 5 of model evaluation, where we discuss the evaluation matrix for the models previously explained in the modeling stage. Model evaluation helps in choosing the best model which generalizes well for unseen data. So basically we make our models learn from the training data set. Then we choose the best hyperparameters using the validation data set. And the final best model that yields from the training and the validation data set is used to is evaluated on the unseen test data set. So for our task of multi-class classification problem, we focus on the class prediction accuracy for the emotions. Now the general evaluation matrix for classification problem are confusion matrix and its derivatives such as accuracy, precision, recall and FN score. Categorical cross entropy loss basically used for validation and overfitting in LSTM, and also the gain and the lift chart, which are used to evaluate classification models on proportions of data rather than the whole data. Now coming to the confusion matrix, the predicted values and the actual values are compared using this matrix, and we have four values such as true positive, true negative, false positive and false negative. Now we have precision recall, F1 score, which is the combination of precision recall and the overall accuracy. Now depending on our task, precision is important or recall is important or the accuracy is important. Now coming to the results. So as explained in the modeling stage, we first begin with three categories of sentiment, and we analyze the basic model of KNN, naive decision tree and MLP for those three sentiments. We have plotted the accuracy, precision, recall and FN score for the testing dataset for all these basic models. We can see that the naive model and the MLP model performs best across all the matrix. However, by the way, we have used sklearn to implement these models. So MLP is quite computationally heavy for training in sklearn. So for simpler tasks such as sentiment analysis, we can use the simpler models such as naive, which only depend on the counts. Now, once we extend the sentiment analysis to sequence models such as LSTM and BioSTM, the overall accuracy shoots immediately. Again, proving that sequence learning models are best suited for text classification problems. Now, we plot the gain and the lift chart to observe the classification model as the data proportion increases. We have plotted for positive, negative and neutral classes, and also we have compared the performance with a random classifier. So here you can see the target score refers to the softmax score in the BioLSTM model, and we have projected it the score from 0 to 1 to 0 to 100. And you can see as the entire data set reaches, the plot converges to 100. And similarly, I've used the lift chart for BioSTM for sentiment analysis. So lift score is basically calculated using target divided by the population, and a random classifier has a 1. Now, moving to 6 categories, which refer to the broader categories of emotions. We now again plot KNN, naive-based decision trees, and MLP. Now, over here, we can clearly see that MLP outperforms even naive-based in terms of accuracy. One interesting observation over here is that naive-based has extremely high precision. However, it has very low recall, and thus the overall F1 score is quite low. So, thus, it shows the importance of F1 score as a combination of precision and recall. However, since we are concerned with the overall accuracy, we see that MLP outperforms all the 3 models, which again agrees with our intuition that more complex models are needed to process large sequential data and more complex tasks. So moving to sequence model of LSTM and BiLSTM, we see that again LSTM and BiLSTM outperforms the basic models of Nebase and MLP in terms of accuracy. Now, this is the testing accuracy after hyperparameter tuning and finding the best parameters. And since we have multiple classes, we have used average accuracy across all the classes. So here are some sample test results for 6 categories. As you can see, these are the correct classifications. I do not know what that is. So the predicted label is neutral and the actual label is neutral. Thank you so much is joy and the actual label is joy. And some ambiguous text such as are you kidding me really, which even humans can misclassify based on the tone, joy and anger. So the model is quite good in predicting the label. Moving to the final 28 categories, we compare the naive-based and the MLP models to the sequence models of LSTM and BiLSTM. Here again, clearly the BiLSTM models outperform the naive-based and MLP, and there is a lot of scope for improvement in the BiLSTM models in terms of more complex sequence models. So, for 28 categories, analyzing the accuracy, classifications, and misclassifications of each particular emotion was difficult since there are so many categories. So, we have used this plot of confusion matrix from which has been developed by the Google research team. So, here they have the predicted labels on x-axis, and here they have the true labels, and they have used the heat map to plot the proportions of predictions, and they have also grouped emotions based on the sentiment. Here are the negative sentiments such as disgust, anger, annoyance. Here are the green ones are the positive such as joy, caring, love, optimism, and here are and yellow refers to some ambiguous emotions. So the dark colors represent that the proportions of predictions are high, and thus they are we can see that the diagonal has a high proportion of predictions indicating true classifications, and we can see that the model confuses the emotions that are related in intensity or sentiment. For example, over here we can see anger is confused with annoyance, which is natural, and we can see disappointment and disapproval getting confused. We can see sadness and remorse getting confused, and even on the positive end we see admiration and pride getting confused. So this is quite useful image to analyze what the model is correctly predicting and what the model is, which emotions the model is confusing in.